Okay, so if you notice, our objective is not on here. Okay, everybody look. Sure, you with me? You with me? Okay, our objective is not on here, but it is on the board. So we are talking about inscribed angles. Okay, so our objective today is to apply the properties and theorems of inscribed angles to solve for missing angles and arcs. So it's up there on the board, and I'm going to also write it here. So I can apply the properties and theorems of inscribed angles to solve for missing angles and arcs. I know. It takes a lot longer to write, doesn't it? And I haven't written a lot today, so I'm like, ooh, I'm not writing very well. Okay, so day one, I think there was a mention of inscribed angles on day one because we talked about central angles. Okay, so today we're just taking a closer look at inscribed angles. Oh, wait. Anybody need more time? Okay. So an inscribed angle is an angle whose vertex is on the circle. Okay? If it's not on the circle, it's not inscribed. So the vertex is on the circle and the sides are chords. Okay? So our example here is angle ACB, or you could call it angle BCA. So angle ACB, or you could call it angle BCA. C has to be in the middle because that's the vertex. Now, if the vertex were on the center, that would be a central angle. That's the difference, okay? This vertex is on the circle, so that makes it inscribed because it's inside the circle. Now, an inscribed angle, okay, will intersect an arc. Okay, so the points that are on the chords here of the angle, they create this minor arc, and that's called the intercepted arc. Okay, so they touch each other. So the angle touches the arc. Does that make sense? Okay, so our intercepted arc will be arc AB. Oh, I put a segment. It needs to be an arc. Or you can call it arc BA.
I think you Oh.
Okay, so we've got a theorem, and it has a name. It's called the inscribed angle theorem. Are you guys with me? Okay, inscribed angle theorem. What it says is that if you have an angle that's inscribed, so if I look at the circle, I have an inscribed angle, A, B, C, okay? The measure of the angle will equal half the measure of the arc. Or you could say the arc, right, will be twice the angle. Does that make sense? So the arc here is AC. That's the intercepted arc. The angle is the ABC. So let's say my arc is 60. That means my angle is half that, would be 30. Or if I knew my angle was 30, I would double it to get my arc. Does that make sense? So the arc is going to be bigger. Okay, so we're going to use that theorem in order to find these arcs and angles down here, okay? All right, so this says use the circle to the right. We're going to use this circle to find the following. So the first one is the measure of arc PT. So I'm going to make that a color so you can see it better. So arc PT would be there in blue. So this is the arc. The angle, the inscribed angle that intercepts it is right here, PQT. Do you see that? This angle is the one that intercepts it. So if the angle is 60, how do we get the arc? Yep, times 2. You just double it, right? So this would be your 60 times 2, which is 120. So this is 120. Okay. Now B says we want the measure of angle PRS. So angle P to R to S. Okay, so if you'll notice, its arc goes beyond PT, it goes to PS. So what do we do to find, so what do we do first in order to find the angle? What do you have to do first? Yeah, you have to add those, 120 and 30, which is 150. So the arc, PS, is 150. So how does that relate to the angle? Good, divided by 2. So we would take the 150 and we divide it by 2. Is what, 75? So it'd be 75. So this angle right here, 75. Okay. So again, we took PT and we added it to TS. We got 150. And then it's half of that, which is 75. Okay. C says we want the measure of angle PQR. So P to Q to R is this angle right here. And it says that arc RS, this arc right here, is 60. Okay, so if I go from the ends of the angle here, from P all the way to R, that's my intercepted arc. Okay, so the first thing I need to do in order to find the angles, I need to add these together, right? Yes, so 210, so arc, and that's more than 180, right? So that's a major arc. So PTR is the major arc. 210. So how would we get this angle? What would we do with 210? Yeah, divide by 2. So 210 divide by 2, 105. Questions on that? Okay, so that's the inscribed angle theorem. Now we've got corollaries to it. Remember, corollaries are just baby theorems that come from the theorem. Okay, so the first one says if you have two inscribed angles that intersect the same arc, they are going to be, anybody know? They intercept the same arc, they'll have the same measure, which means they will be congruent. Yeah. Congruent. So if you look right here, angle B is this angle right here, A to B to D, and it intercepts AD, right? And then angle C is this angle right here, A to C to D, and it intercepts AD also. So since it intercepts both intercept AD, that means they are congruent. So this one is congruent to this one. Okay, the second corollary says an angle inscribed in a semicircle is a blank angle. Okay, so here's how we can figure this out. Semicircle, remember, is 180, right? So this angle, or sorry, this arc is 180, and remember the angle that intercepts it is half that. So what's half of 180? 90, right? So this would be 90. So anytime an angle intercepts a semicircle, it always has to be a right angle. Does that make sense? Okay, because this is 180, because that BC is a diameter. So 180, and then half that, this is 180. Half that would be 90. And so anytime you intercept a semicircle, you have a right angle. Okay, then the last corollary says, if a quadrilateral is inscribed, and inscribed is inside where your vertices touch the circle, okay, then the opposite angles are going to be, anybody have a guess? Supplementary. They could be congruent, but not necessarily. But they are supplementary. Okay. So what it's telling you down here in this one, when I add angle A and angle C together, I should get 180 because they're supplementary. And when I add angle D and angle B together, I should get 180 because they're supplementary. Okay? And since they're supplementary, 180, 180, 180, right? You have 360 altogether because it's a quadrilateral. See how that goes with what we did before? Okay. All right. So we're going to use those in some examples. Do a little flip. Okay, so example 2, we want to find A and we want to find B. I think it's nice to find A first. Okay, we have to find A first actually. So if we find A, here is our angle, right? And it intercepts this arc right here. What do we know about this arc? Yeah, it's a semicircle. So if it's a semicircle, what does A have to be? Good, A is 90. Okay, so for B, if we follow the angle that goes with the arc for B, that angle is this one right here. Okay, and this is the arc here. So we need to know this angle, right, to get B? Okay, how can we get this angle, then get B? What should we do? What shape do we know here? Yes, it's a triangle. So can we get the third angle of the triangle? Yeah. What do we do? Good. We can subtract them from 180. Okay. So if I subtract 90 from 180, I have 90, right? So really I can just subtract 90 minus 32. Because these are complementary. Okay. So that gives me, what, 58? Okay, so this angle right here is 58. So if that's 58, how do I find the arc? Good, times 2. So we'll take 58 and I will double it. And what does that give me? 116? Is that right? I think so. 50 and 50 is 100. 8 and 8 is 16. Excellent. Questions on that? I feel like I'm drawing ice cream cones. Right? Weird ice cream cones. I don't know. That's just me. Maybe I'm hungry. I like ice cream. Okay. Questions on example 2? Okay. Example 3. We want x. What do you notice in this one to help us find x?
Oh, wait.
And why are they congruent? Yeah, they intercept the same arc, right? See how the 60 degrees intercepts arc AB? And then this angle also intercepts arc AB. So if they intercept the same arc, they have to be congruent. So x is going to equal 60. They are the same. That's this corollary right here, this one. If they intercept the same arc, they are congruent. Okay. Questions on that one? Okay. Arc M, N, O. So M to N to O. This arc right here is a semicircle. So what does that mean? Yes, so if this piece is 80, what's this piece?
100.
Good. Okay. Right, so that means that this is a diagonal right here if I drew it, right? Okay, so we've got 180 here. Okay, so if this is a semicircle, what do I know about arc MLO? Good, also a semicircle. So if this part is 60, what's this part? Good, 120. Okay. So now we can find our degrees on the inside. So if it intercepts, so Y's angle, right? This angle here intercepts a semicircle. What do we know about its degree? This is 180.
90.
Good. Y is 90. Which makes W what? Also 90. Okay, because those both intercept semicircles. Okay, and they have to be supplementary. So if Y is 90, W has to be 90 because they have to equal 180. Okay, so these are both 90. Okay, now X, okay, where X is, those endpoints are L to N. So N intercepts this arc, L, O, N, right? So what do I have to do first? Good, so I'm going to add, which ones? That's for Z. I could do that though. Let's do Z. So Z, I'm going to add 60 and 80 because that's what it intercepts, right? What's 60 and 80? Yeah, so 140. So how do I find Z then? Good, divide by 2. So Z will be 140 divided by 2, which is 70. Now, I can do the same thing for X, or I can just subtract from 180 because X and Z are supplementary, right? So if Z is 70 and I subtract from 180, what do I get? Good, 110, good. So I would just take 180 minus 70, and that gives me 110. Questions? Okay. All right. We got another one that has a quad that's inscribed. Okay. We want to find the angle X and the angle W. Okay. So what is going to help me to find angle X? Which one helps me with angle X?
Y.
Z. We want the one across. Because the one across is going to be what to angle X? Supplementary, right? Okay, so what do I do with 60 degrees to get X? Good, I'm going to take 180 minus 60, and that gives me 120. So this is 120. Okay, now how do I go about finding W? Which angle helps me with W? Y. Okay, angle Y helps me with W. What do I do to find W? There you go. Good. 180 minus 95. 85? Excellent. My brain hasn't completely shut off. Okay, questions so far? Not too bad? Okay, this one can be kind of tricky, all right? Notice we don't have a full quadrilateral, right? We only have a triangle. So we've got to know kind of what kind of triangle is this. Yeah, how do we know it's right? Good, it intersects a semicircle. F, and it should have another point here, but F to H is a semicircle because this is a diameter. So G would be a right angle. Okay, so if G is a right angle, what do we know about F and H? Yes, they equal 90. They are complementary. Okay, because the whole thing has to be 180, right? Okay, so we are going to add them together and make them equal to 90. So I have 9x minus 3 plus 4x plus 2, and they equal 90. Does that make sense why they equal 90? Okay. Combine our like terms. 9x and 4x is 13x. Negative 3, positive 2 is a negative 1. Equal to 90. Add the 1, 13x equals 91. Divide. Yes, 7. All right, but how do I find the measure of angle F? Good, plug it in. So I'm going to have 3, not 3. I'm reading it backwards. 9 times 7 minus 3. So 9 times 7 is 63. 63 minus 3 is? Good, 60 degrees. Questions on that one? Okay, now, this proof, don't let it intimidate you, right? You're given all of the justifications, okay? We just got to fill in the statement. So what's the first statement going to be? Yeah, it's the given, circle C. What's the last statement going to be? The proof, right? Triangle KML is similar to triangle JMH. Now, do you see the justification for it? Angle, angle, right? So angle, angle means I've got two pairs of angles that are congruent. Okay? So if we look here, the first one says inscribed angles intercepting the same arc are congruent. So we need to find which inscribed angles those are. Okay, so which are the ones that intercept the same arc? Good, this one, HJL and LKH, right? They intercept this arc right here, HL. Okay, so we're going to name HJL, so angle HJL is congruent. Okay, it's congruent to its counterpart over here, LKH. Okay, now, the second justification here, well, that's actually the third, but the second one is vertical angles are congruent. So where are my vertical angles? Because I'm looking at these triangles right here, right? Which ones are vertical? I'm looking at, I'm looking at this one here. I'm going to like shade them, right? And this one here. Yes, LMK and HMJ. So this one right here, it's so tiny, I'm sorry. This and this. So LMK, so angle LMK is congruent to angle H. I put triangle, it should be angle. Triangle HMJ. And we're done. Okay, questions? All right, I do have some practice for you, and I have the review for you. On the practice, though, when you get it, like, don't put it away right away, because there are some that you don't have to do, and I'm going to tell you which ones they are. All right, let me